let's start. I'll just put the fraction line in there, and I've got 2x plus 1 as an exponent, and then 15 becomes 3 times by 5, and on the outside of the brackets I'm raising it to the power of 2x minus 3. In the denominator, 27 is the same as 3 cubed, and I'm raising that to the power of x minus 1. And then 3 to the power of x stays the same because the base is already a prime number. And the same thing with 5 to the power of 2x minus 5. Okay, so let's make it look neater. Now I'm going to get rid of those brackets, so I put an equal sign. I'm leaving everything else the same. If I do too much in one step, I'm going to confuse myself, and I am going to confuse everyone else. So what I'm doing is I'm taking that 3 and I'm raising it to the power that's on the outside of the brackets. And it might actually help you if you think of it as having its own set of brackets there. But let's carry on, and I'm going to multiply it by 5 to the power of 2x minus 3. And over, and then at the bottom I've got 3 to the power of 3x minus 3, and that's actually why I say it might help to put it in brackets, because then you remember to multiply both the x by 3 and the negative 1 by 3. Now we're going to do 3 to the power of x and 5 to the power of 2x minus 4. Okay, moving down. Let's just give me a bit of space. I'm now going to gather bases that are the same. I have 3 to the power of 2x and 3 to the power of 2x again. The bases are the same, which means I can add the exponents. And I also have 3 to the power of 1 and negative 3. When I add those together, I am going to get negative 2. So there we go. And I'm multiplying that by 5 to the power of 2x minus 3. There's nothing more I can do with that as it is. So I'll write it. And then in the denominator, I've got 3's. They're the same base, so that means I can add the exponents because they're multiplying by each other. So that gives me 3 to the power of 4x minus 3 times by, and then I've got 5 to the power of 2x minus 4. So some of you are going to look at this now and go, but Helen, you can just cancel off and all of those things. And yes, you can. But to avoid a little bit of confusion, I'm going to rather, as a teacher, bring all of these exponents that are on the bottom, or all of these numbers, I suppose, factors that are on the bottom, to the top, which means I change all of the exponents to the negative version of themselves. So I'll start with the numerators, and then I'm going to skip a step and I'm just going to throw those up there. So it was positive 4x, it now becomes, and I'll do it in blue, negative 4x. So it was, and then it becomes negative. It's also negative 3. If I multiply that by negative 1, I'm going to get 3. Now I've got 5, and in the numerator it was 2x minus 3. In the denominator I had positive 2x, which means if I bring it to the top it becomes negative, and I'm minusing 4, so that means I'm plusing 4 up here. Now it looks a lot more pretty, because now I can see that I have got 4x and I'm subtracting 4x. Then I've got, so that gives me nothing. And I've got minus 2 and I'm adding 3, so that gives me 3 to the power of 1. Do I need to write the 1 there? No, I don't. I can just erase it. But just so you know, that's what's going on. Then I've got 5 to the power of 2x and I'm subtracting 2x from it, so that gives me nothing. And then 5 to the power of negative 3 plus 4, that's going to give me 5 to the power of 1. And of course, we know that 3 times 5 is 15. Once again, there is more than one way to do this question, so you just really choose the method that works best for you. When we're asked to solve for x and x is in the exponent, it means that we want to have our bases the same. And obviously half is not the same as 32. But because I've had lots of practice, I can see that I can change both of them to be 2 to the power of something. On the left side, I can see that it will be 2 to the power of negative 1. And then on the right side, that is going to be 2 to the power of 5. Don't know why I put it in brackets, but let's just take it out. And so, because the bases are the same, let's just multiply this out, 2 to the power of 5. Because the bases are the same, we know, because of logic, if that's the same as that, it means that this up here will have the same value as that over there. In other words, negative x will have the same value as 5, so that means that x must have a value of negative 5. The important thing with question 2.2.2 is to not get overwhelmed by what you see. In fact, that's the important thing with any exam question. As you can see, it's only worth 3 marks, which means this should be a relatively quick problem to do. So I see that this whole side is cube rooted. And if I want to get rid of my problems, which is cube root, I am going to start by cubing both sides. So that will give me 1 over x squared is equals to, let's just cube root it or cube it, and we get to 64. Now I'm hoping to get to a point where I've got x to the power of something is equals to a number to the power of the same something. In order to do that, I'm going to factorize that, do prime factorization, and we will find that we have 2 to the power of 6. So we need to get this now to be to the power of negative 2. I'll show you what I mean. So I've got x to the power of negative 2. I've got to have 2 to the power of something to the power of negative 2. So what times by negative 2 will give me 6? And the answer there is negative 3. Because our exponents are the same, I've got negative 2 and I've got negative 2, it's almost like I can drop them, because I know that if the exponents are equal to each other, then the bases are automatically equal to each other. So I know that x is equals to 2 to the power of negative 3, which means x is going to be equal to 1 over 8. Question 2.2.3 is a bit of a tricky one. And that's why it's so important to practice, because if you can see what the tricky bit is, you can figure out how to do it in a short amount of time. You have 5 marks allocated to this, so it should take you roughly 6 minutes to do. Now, my coping strategy with questions like this is I am going to say that 2 to the power of x is equals to k. And you'll see why I do that. So I've got k minus 12 over k is equals to negative 4. I want to get rid of k in the denominator, which means I'm going to multiply everything by k across, and I'm going to get k squared minus 12 is equals to minus 4k, and we can see that we're going to have a trinomial that needs to factorize, so we rearrange it so that we can do that. If I had left it as 2 to the power of x, I would have had 2 to the power of 2x plus 4 times 2 to the power of x minus 12. So this just makes it easier to cope with. Let's factorize, and it's going to be k and k, and one's going to be minus and the other one's going to be plus. And 2 times by 6 gives me 12. So that means k is equals to 2, or k is equals to negative 6. So remember that I started by replacing k, or 2x, 2 to the power of x, with k. So I'm going to just do that back again. And here's where a tricky thing is. 2 to the power of x and negative 6. How can we make that work? And the answer is we can't. 2 to the power of x is never going to give me anything that's negative 6. So that means 2 to the power of x is equals to 2 to the power of 1. So x must have a value of 1. There we go. It's done. Let's zoom out. So my coping strategy was to replace 2 to the power of x with k so that I could then factorize easily. And then once I got to over here, I was able to substitute 2 to the power of x back in, and I was able to determine that this would never be a solution. So question 2.3 is not easy. It says, without using a calculator, show that this ugly thing over there simplifies to that over there, which isn't much more pretty, but it's still okay. So obviously over here I don't have a denominator, which means over here I'm going to somehow try and get rid of those denominators. In order for that to happen, well, it's an expression, so I've got to add the fractions together. To do that, I need to find a lowest common denominator. You don't have to write this on the side. I'm just doing it because I am a teacher and I want to show you all of the steps that I'm going to do. So I find the lowest common denominator by just multiplying the denominators together. And it is going to look a little ugly, but let's start actually just by writing the lowest common denominator at the bottom, well, in the denominator. And then in the numerator, I can start by changing all of those numerators by multiplying them. You'll see what I mean. So I am multiplying square root 2 by square root 2 because that's how I'm changing it to a common denominator. Then on the other side, I'm just going to show this calculation. It was 4, and I now have to multiply it by the square root of 2 plus 1. So I have shown that step. I'm going to do something rather strange and keep it as square root 2. And it will become apparent very soon. Plus 4. And then at the bottom, let's multiply that out. We've got square root 2 squared plus, and then the square root of 2. Okay, if I look at the numerator, I can see that I have got, let's do it in color to the side, I have got a trinomial that I can factorize. And that is actually why I have chosen to leave all of them as square root 2 for now, because it's easier for me to see the trinomial that way. If I were to factorize this normally, I could see that I would get, it's a perfect square, so it's going to be x plus 2. So let's just show that on the other side, or on my calculation side. But instead of x, it's going to be the square root of 2 plus 2, and that's going to be squared. And this is where it starts looking exciting. At the bottom, I've got all of this happening. Now I'm going to square that, and you'll see why. So it's square root of 2 squared is going to be 2 plus the square root of 2. So where have I seen that? Well, firstly in the answer, but I've also seen it happening over here. Going to make this more obvious. Square root of 2 plus 2 times by the square root of 2 plus 2. And the denominator, I'm just going to use the commutative property and write it in the other direction, and look at that. That cancels with that, and we are left with square root 2 plus 2. And that's it for now. Much love.